Space, the final frontier, but not a breath of air. Space is big, really big, and it's mostly empty. When we look up at the night sky, we see countless stars, planets, and galaxies. But between these celestial bodies lies an immense void, a vacuum that stretches across the universe. That emptiness, what we call a vacuum, is one of the defining characteristics of the cosmos. It's a place where sound cannot travel, where there's no air to breathe, and where the temperature can plummet to extremes. But what if it wasn't? What if the vast expanse of space wasn't a cold, airless void? What if space, instead of being a vast, airless void, was filled with air? Imagine a universe where the vacuum of space was replaced with an atmosphere similar to Earth's. How would that change our understanding of the cosmos? It's a mind-bending thought experiment, one that forces us to confront our understanding of the universe and our place within it. Would planets still orbit stars? Would galaxies still form? How would life evolve in such an environment? Let's embark on a journey into this hypothetical cosmos and explore the awe-inspiring and sometimes terrifying possibilities. Imagine spacecraft navigating through an atmosphere, encountering resistance and drag. Picture stars shining through a hazy sky, their light diffused by the air. Consider the implications for space travel, communication, and even the fundamental laws of physics. In this alternate universe, the very fabric of space would be different. The absence of a vacuum would mean that the principles of motion and energy transfer would change. Spacecraft would need to be designed differently, with engines capable of overcoming air resistance. Communication signals would travel differently, potentially being absorbed or scattered by the air. The presence of air in space would also have profound effects on the formation and evolution of celestial bodies. Planets and stars might form differently, with atmospheres playing a crucial role in their development. Life, if it existed, would have to adapt to these unique conditions, leading to entirely new forms of biology and ecosystems. As we ponder this fascinating scenario, we gain a deeper appreciation for the delicate balance of forces that shape our universe. The vacuum of space, though seemingly empty, is a fundamental aspect of the cosmos that allows for the existence of stars, planets, and life as we know it. So, while the idea of an air-filled space is intriguing, it also reminds us of the incredible and intricate design of our universe. The final frontier, with its vast emptiness, is a testament to the wonders of creation and the mysteries that still await our discovery. Air everywhere? A recipe for cosmic chaos. First, we need to understand why space is a vacuum. Space, as we know it, is an almost perfect vacuum, meaning it has extremely low density and pressure. This is vastly different from the environment on Earth, where air is abundant and essential for life. The answer lies in gravity. Gravity is the force that attracts objects towards one another. On Earth, gravity is strong enough to hold our atmosphere close to the surface, creating the air we breathe, or rather, the lack of it in most parts of space. In the vast reaches of space, far from any massive objects like planets or stars, gravity's pull is incredibly weak. This is why space is mostly empty, with only sparse particles and radiation. On Earth, gravity holds our atmosphere close to the surface. This atmosphere is composed of various gases, primarily nitrogen and oxygen, which are crucial for life as we know it. But in the vast expanse between planets and stars, gravity's pull is much weaker. This means that any gases present would not be held together and would spread out, creating the vacuum of space. Without a strong gravitational force to hold it down, air would simply dissipate into the cosmic void. Imagine releasing a balloon in space. The air inside would quickly spread out and vanish into the emptiness. So if space were suddenly filled with air, it wouldn't last long. The air would rapidly disperse, unable to stay concentrated in one area due to the lack of gravitational forces. Gravity would eventually pull it towards the nearest massive objects like stars and planets. These celestial bodies would attract the air, creating dense atmospheres around them, but leaving the vast stretches of space still largely empty. This process would create pockets of air around planets and stars, but the majority of space would remain a vacuum. The air would not be evenly distributed, leading to chaotic conditions. The introduction of air into space would also have dramatic effects on space travel and exploration. Spacecraft and satellites are designed to operate in a vacuum, and the presence of air would create resistance, altering their trajectories and potentially causing collisions. Additionally, the presence of air would affect the temperature and pressure conditions in space. Currently, space is extremely cold, but air could introduce heat through friction and other processes, changing the thermal dynamics of the cosmos. In summary, while the idea of air everywhere in space might sound intriguing, it would lead to a host of complications. The delicate balance of the cosmos would be disrupted, creating a recipe for cosmic chaos. Space, in its current state, is a finely tuned environment. The vacuum of space is essential for the stability and order we observe in the universe. Introducing air would only lead to unpredictable and potentially catastrophic changes. So, while it's fascinating to imagine, the reality is that space is best left as it is, a vast, empty, and mysterious frontier. Air everywhere, a recipe for cosmic chaos indeed. Rockets on standby space travel gets a makeover. Imagine launching a rocket into space, not through the vacuum we know, but through a thick soup of air. It would be like trying to fly a plane through honey. Air resistance, which is minimal in our vacuum-filled space, would become a formidable obstacle. Rockets would need drastically different designs, perhaps resembling sleek, aerodynamic jets rather than the bulky, fuel-guzzling behemoths we're accustomed to. Space travel, as we know it, would be revolutionized. Star power dimmed the fate of celestial objects. Stars, those distant suns that illuminate the cosmos, wouldn't fare well in an air-filled universe. Stars generate energy through nuclear fusion, a process that releases immense amounts of light and heat. In the vacuum of space, this energy travels unimpeded. But air is a different story. Air molecules would absorb and scatter starlight, dimming the brilliance of the cosmos. We might not even be able to see stars from Earth. Section 5, Planets in a Fishbowl. New atmospheres, new challenges. Our own planet wouldn't escape unscathed. The sudden influx of air into space would dramatically alter Earth's delicate atmospheric balance. Temperatures would soar as the air trapped heat from the sun. Imagine a runaway greenhouse effect, far more extreme than anything we're currently experiencing. Life on Earth as we know it would face an existential threat. Section 6. Cosmic concerts and muffled explosions. The sounds of space. Sound, unlike light, needs a medium to travel. In the vacuum of space, there's no sound. But an air-filled cosmos? That's a whole different symphony. Imagine the roar of distant stars, the whoosh of comets streaking across the sky, the echoes of supernova explosions. Space would become a cacophony of cosmic sounds, a testament to the universe's boundless energy. Section 7. A sky full of stars, up close and personal. Remember those twinkling stars we talked about? Well, in an air-filled universe, they wouldn't just be dimmer, they'd be closer. Much closer. Air molecules would scatter starlight, making the universe appear much smaller than it actually is. Stars that are currently light years away might seem close enough to touch, their light distorted and diffused by the intervening air. Section 8. Life, but not as we know it. The search for extraterrestrial neighbors. The search for extraterrestrial life is one of the most profound scientific endeavors of our time. For centuries, humans have gazed at the stars, wondering if we are alone in the universe. With advancements in technology, our quest has become more sophisticated, involving complex instruments and international collaborations. But in an air-filled universe, the very definition of life might need to be rewritten. Traditional concepts of life are based on carbon and water, but what if life elsewhere is built on entirely different elements? The possibilities are as vast as the cosmos itself. Could life as we know it, based on carbon and water, even exist in such an environment? Perhaps. Scientists are exploring extremophiles on Earth, organisms that thrive in conditions previously thought uninhabitable, to understand how life might adapt to alien worlds. Or perhaps life would take on entirely new forms, adapted to the unique challenges and opportunities of a breathable cosmos. Imagine creatures that breathe methane instead of oxygen, or beings that communicate through electromagnetic waves. The search for extraterrestrial neighbors is not just about finding life, but understanding the myriad ways life can manifest in the universe. This quest pushes the boundaries of our knowledge and challenges our understanding of biology, chemistry, and even the nature of existence itself. As we continue to explore, each discovery brings us one step closer to answering the age-old question, are we alone in the universe? Section 9. Human ingenuity takes flight. New technologies for an air-filled cosmos. Humans are nothing if not adaptable. Faced with the challenges of an air-filled universe, our ingenuity would undoubtedly soar. We might develop new propulsion systems that harness the very air that surrounds us, allowing us to navigate the cosmos with unprecedented ease. Spacecraft might resemble graceful airships gliding through the cosmic currents. Section 10. Rethinking the universe, our place in a breathable cosmos. The idea of a universe filled with air challenges our fundamental understanding of the cosmos. It forces us to confront the vastness of space, the power of gravity, and the delicate balance of conditions that make life on Earth possible. It reminds us that our place in the universe is both precarious and precious. Section 11. The Great Cosmic Breath, a universe teeming with possibilities. While the idea of an air-filled universe might seem like pure science fiction, it serves as a powerful thought experiment. It pushes the boundaries of our imagination and inspires us to ask profound questions about the nature of reality. And who knows, maybe somewhere out there, in the vast expanse of the cosmos, exists a universe where the stars whisper secrets on the cosmic breeze.